Hello all, myself Vikas Verma. In this presentation, we are going to discuss about diode clippers and clipping circuits. Coming to the introduction part, most of the electronic circuits like amplifiers, modulators and many other have particular range of voltages at which they have to accept the input signals. Any of the signals that have been an amplitude greater than its particular range may cause its output distortion of the electric circuits and may even lead to damage of the circuit components. The clipping of a waveform is the most common technique that applies to the input signals to adapt them so that they may lie within the operation range of the electronic circuits. The clipping of the waveforms can be done by eliminating the portions of the waveform which crosses the input range of the circuit. Now, what is a clipper? A diode clipper, also known as the diode limiter, is a wave shaping circuit that takes an input waveform and clips or cuts off its top half or bottom half or both halves together. So here comes the clipping. Clipping changes the shapes of a waveform and alters its spectral components. A clipping circuit consists of the linear elements like resistors and non-linear elements like diodes or transistors, but it does not contain energy storage elements like capacitors. Now, what is diode clipping circuit? A diode clipping circuit can be used in a variety of applications to modify an input waveform using the signals and Schottky diodes, or to provide the over the voltage production using Zener diodes to ensure that the output voltage never exceeds a certain level, protecting the circuit from high voltage spikes. The diode clipping circuits are basically used in the voltage limiting applications. Now, coming to the types of the clipper circuits, we have two types of clipper circuits. They are series clippers and shut or parallel clippers. Now, coming to series clippers, there are both series positive clipper and series negative clipper. And after we have biasing the clippers. So, coming to the series negative clipper, this is a basic clipper circuit using a diode, and it is nothing but a half wave rectifier. So, from the following circuit, it is clear that the diode is forward biased during the positive cycle and acts as a closed switch. Hence, the output is equal to the positive half of the input voltage. And during the negative cycle, the diode is reverse biased and acts as open switch. So that results in zero voltage output. So from this diagram, in series negative clipper, the output voltage during positive half cycle is equal to input voltage minus diode threshold voltage. So output voltage during negative half cycle is 0 volts. When it comes to series positive clipper, it is simply obtained by reversing the diode. So the cathode is connected to the positive of the power supply and anode is connected to the load, which makes diode reverse bias for positive cycle and forward bias for negative cycle. During positive half cycle, output is 0, and during negative half cycle, output voltage is V input voltage plus diode threshold voltage. And coming to shut positive clipper, the anode is connected to the power supply through the resistor and the cathode is at ground potential. So the conditions are: during positive half cycle, output voltage is V diode voltage, and negative half cycle output voltage is equal to V input voltage. And shut negative clipper, and in shut negative clipper, cathode is connected to the power supply through the resistor R and anode is maintained at the ground potential. So during positive half cycle, V output is V in voltage, and during negative half cycle, V output is equal to minus V diode threshold voltage. So coming to the biasing of this clipping circuits, uh, first positive bias diode clipping, like we observe in the diagram, it clips the positive half cycle of the waveform, like reversing the diode and the battery bias voltage. When a diode conducts a negative half cycle of the output waveform is held to a level negative bias minus 0.7 volts shown in the above picture. And when it comes to the negative bias diode clipping, a variable diode clipping is achieved by varying the bias voltage of the diodes. The positive bias voltage could be at one level, for example 4 volts, and negative bias voltage at another level 6 volts. If both positive and negative half cycles are to be clipped, then two bias clipping diodes are used. but for the positive and negative diode clipping, the BIOS voltage need not to be the same. So here comes the Xenon diode clipping. It is Xenon diode is acting like a basic diode clipping circuit, which the BIOS voltage being equal to the Zener breakdown voltage. In the circuit during the positive half cycle of the waveform, the Zener diode is reverse biased, so the waveform is clipped at Zener voltage. During the negative half cycle, the Zener diode acts like a normal diode, so it has a usual junction value of 0.7 volts. So we can develop the idea further by using Zener diodes reverse voltage characteristics to clip both half cycles of the waveform using series connected back-to-back Zener diodes. We can see that in the diagram. So what are the applications of diode clippers? So there are many applications. When we talk about them, they are used to generate the shape of the waveform, and power supply units consisting of clipper circuits and FM transmitters to remove the excess amount of ripples. Clipping circuits are used, and clipping circuits are used to protect the transistors from transistors that diode are conducting in a parallel manner with a load that is inductive by nature. And they are also used applicable for frequently used half wave rectifier in power supply kits is a typical example of a clipper. It clips either positive or negative half cycle of the input. And diode clippers can be used as voltage limiters and amplitude selectors. Coming to the conclusion part, as well as being as rectifiers, diodes can be used to be clip the top or bottom or both the waveform at a particular DC level and pass it to the output without distortion. Diode clipping circuits are used to eliminate amplitude noise or voltage spikes, voltage regulation, or to produce new waveforms from an existing signal, such as scaling of the peaks of a sinusoidal waveform to obtain a rectangular waveform as seen above. And the most common application of a diode clipping is a flywheel or freewheeling diode connected parallel across an inductive load to protect the switching transistor from reverse voltage transitions. With this, we can end our presentation. Thank you.